All right, folks. As we are preparing to take what I can only describe as a speed run through the final three chapters of CCNA 3, Connecting Networks, I wanted to discuss the labs themselves, and more specifically, the topologies. We've got 6 labs, but we don't have 6 topologies. Technically speaking, I suppose we have um, 6 physical topologies because really and truly um, IPv4 and IPv6 are completely separate from each other. They have a lot of the same basic concepts. They both use the same kinds of transports, TCP versus UDP, multicast versus unicast, etc., etc. But at the end of the day, we are dealing with less than 6 physical topologies. Now, with these first 2 labs, OSPF v2 here and OSPF v3 here, we obviously have precisely the same physical topology. We've got 3 routers in a ring with serial interfaces. We've got some computers hanging directly off those gig00 ports, which I grant is very unusual and you should never do in the real world. But frankly, for the purposes of layer 3 protocols, the switch is invisible anyway, so we're kind of ignoring it. What we have here is one and only one physical topology, bound by 2 logical topologies. Now, I know this because I also looked at other pieces of these instructions for these labs, specifically the hardware. So we've got 3 routers, 1941s with the 15.2 universal K9 image or something comparable. For our purposes here, it doesn't matter if it's the universal K9 or the universal NPE. We're not doing SSH that I know, so crypto doesn't matter. And to prove the point, we can scroll down a little bit, and we've got 1941s, 3 PCs, Ethernet and serial as configured, and we can even see that the logical topologies are more or less congruent with each other. I've got gig00 in my access layer. I've got my S000 TCE, S0001, and that's true all the way down the line. I've got each PC in a separate subnet. Now with v6, each router has its own link local. You'll give the same link local address to each interface on a given router. This is very important because some of your v6 routing protocols use link local specifically. Like for example, type 8 LSAs in OSPF v3 only work on the local link. So if you don't give your routers link local addresses, they don't know who to talk to. No. Okay, so that's chapter 4. That's chapter 8. Let's look at chapter 9. So chapter 9. Let's go to 9.8 and 9.9. Okay, 9.2.2.8 and 9.2.2.9. Now, these don't look like the same topology. We've got an area 1 and a 0 and a 3 on one, and a 1 and a 0 and a 2 on the other. And we've got different loopbacks, and there's an internet link over here that isn't over here. But guess what? It is the same physical topology. So what you can do when you're building these things is build one base config and copy it into 2 different files. One base topology in Packet Tracer, make 2 copies of it, and build from there. The thing that makes these one physical topology and 2 logical topologies is that these loopback addresses are logical. They're virtual. You don't have to create any, you don't have to put any sort of new HWIC in the box, the router, to make those loopback addresses possible. You just do interface loopback and the number, and you go from there. So it works. So with our addressing table here, we've got our loopbacks, and so we're using these loopbacks in lieu of, in place of the physical PC. So you're technically speaking, I suppose, let me look at this one, 8. You know what? I bet you could take the beginning of this, your three routers in a ring, and you could use that as the base physical topology for all 4 of these labs in chapters 8 and chapter 9. The only difference here is that you will delete this link here between 1 and 3, because this is single area OSPF, and you want these routers in a ring so they can propagate, and there's a backup path from any point A to any point B, even if one of the routers goes. Now, granted, I say any point A to any point B. If router 3 goes, then obviously you're going to lose all contact with PCC. But what we're doing here in chapter 9 is multi-area OSPF. We're using these loopback addresses to simulate multiple access layer networks in each area. Now, technically speaking, it's a little bit weird to have an access layer network in your backbone area, but it's not totally illegal. So there's that. So we've got essentially one basic topology expressing it in 3 different physical, in 2 different ways physically, and then 4 different ways logically. It is really, really important as you're doing this, and this is more than just getting through the labs for these 3 chapters. What I'm really talking about is understanding your customer's needs, requirements analysis. This is always step 0, as it were, in your systems development lifecycle. Know what the customer needs. To really get down to brass tacks, understand the difference between what the customer wants and what the customer needs. What the customer needs and what the customer can pay for, in point of fact. Because your job is eventually, as an architect, at some point, may be to tell your customer no in the most polite and diplomatic fashion possible. So there's that. Let's also look at chapter 10 right quick, because chapter 10 is where things get a little weird, a little unusual. We stop, in a sense, being able to just use the one topology. So I'll go back here, go to chapter 10. Let me drag this over and do another screen. Okay, boom. So there we have it. And here we very obviously don't have the same topology. In one situation, we've got our 3 routers, and those 3 routers are talking to each other through a switch. So that's a very different animal. The whole point of this lab is this DR, BDR, DR other election. Whereas with this lab, the Advanced Features Lab, we're actually kind of back to the original topology. So I guess I misspoke. So you can take that base configuration and build it out in various ways. Make several copies of it and go from there. Because we've got our access layer network A, our access network layer C over here, and our loopback, but no access layer here. Whereas with this one, we've got a loopback here, a loopback here, a loopback here, and they're all called loopback 0. So pay really close attention to what you're doing as you're doing this. It would be really annoying to put the wrong loopback in the wrong place and get things all mixed up. Probably, you know what, the next thing I'm going to do is build all of this out. Build the basic topology once and replicate it as always, work smarter, not harder. Thanks for watching, and I will see you again soon.